Welcome back, everyone. Before the break, I defined what a polyhedron was. Just a reminder, in case you weren't with us, a polyhedron is a three-dimensional shape that has 4 or more faces. So essentially, it's any type of 3D shape that you can hold. It's not like a 2D shape, which I could draw behind me. If I just drew a plain circle behind me on the board, that's a 2-dimensional shape. Versus me actually holding a ball. We know that that is a 3-dimensional figure. It's the same thing if I were to draw a square behind me, that's a flat 2D object. Versus if I was holding a box of biscuits or a box of chocolates, that is a 3-dimensional shape that's made up of different faces. The different faces of a 3-dimensional shape, we can refer to that as the surface of the shape. So I'm sure that you would say that there are surfaces that make up a box of chocolates. And what the surface area is that we take the area of each face of the shape that makes up the entire figure, and we add the areas of the individual shapes together. So I'm going to say that again. We take the areas of each shape that makes up the 3-dimensional figure, and we add all of those areas together, and that is what surface area is. So it's the area along the surface of the 3D object. Now we're going to get into some examples so you can see how we actually calculate these. Let's go to the board. So we have our first question. We have been asked to calculate the surface area of the following rectangular prism. So we can see we've got a rectangular prism present, and we've been given specific dimensions. So our job now is to calculate the surface area of this shape. So just a reminder from before the break, I defined what the surface area of the shape is. And it's 2 times length times breadth plus 2 times length times height plus 2 times breadth times height. Just a reminder, the reason why I have these 2's is because I have repetitions of the following shapes. We can see that the top rectangle is the same size as the bottom rectangle. So that's why we have 2 times the length times breadth. So this is accounting for the top triangle and the bottom triangle. Then where we have 2 times length times height, this is accounting for this front rectangle as well as the back rectangle. So I'm taking 2 times the area that represents the front rectangle as well as the back rectangle. Then lastly, for the left and right rectangle that make up this box, I'm taking 2 times the area of the left and the right rectangle. But before I actually start substituting in, my advice would be to identify which part of the formula is which. The reason why this is going to help me is just in case you make a mistake in your calculation, at least you've shown your marker that you've identified the dimensions. So I'm first going to write what my length is. I can see that my length is 10 centimeters. So I am going to fill that in. Then I'm going to identify what my breadth is. My breadth is 4 centimeters. Then I'm going to establish what my height is. And the height of this rectangular prism is 5 centimeters. So now I'm going to substitute my L, which is my length, my B, which is my breadth, and my H, which is my height, into the formula. So just in case you're worried about the L's, B's, and H's, they represent length, breadth, and height. So let's do the calculation. The surface area will be equal to 2 times the length, which is 10, times the breadth, which is 4, plus 2 times the length, which is 10, times the height, which is 5, plus 2 times the breadth, which is 4, times the height, which is 5. So let's conduce this a little bit more. I'm going to have 2 times 40 plus 2 times 50 plus 2 times 20. So all that I've done is simplify the dimensions into one bracket because I know that 10 times 4 is 40, 10 times 5 is 50, and 4 times 5 is 20. Now we're going to say 2 times 40, which is 80, plus 2 times 50, which is 100, plus 2 times 20, which is 40, which means that the surface area of my particular shape is going to be 220 centimeters squared. Please just put a little star in your notes or in your books. It is very important that we remember this centimeters squared because it is still representing an actual area that has been covered. Great, everyone. I hope that you're still with me and what I've done that makes sense. Please just remember, for the formula for the surface area of a rectangular prism, identify your length, your breadth, and your height. Substitute them into each part of the formula carefully, and then you simplify. Also, something that should be an alarm bell is if you have the same areas occurring for all of the 3 calculations, because they're different dimensions. So please make sure that you have multiplied your length and your breadth together, your breadth and your height together, and your length and your height together. And we know that each of those have been multiplied by 2. Let's look at the next example together. So we are now going to be calculating the area of the cube if it is open on top. I'm going to stop and pause us there right now. If I've only been given 3 centimeters as one label on my cube, is that going to be a problem? Does that mean I don't actually know what the other dimensions are? I'm going to ask you to sit and think about that for a minute. No. It's not a problem because I know that a cube is comprised of squares, and I know that squares have equal sides. So having that one piece of information that says 3 centimeters means that each side of the cube is in fact 3 centimeters. So this question has a bit of a trick to it. We've been asked to calculate the surface area of the cube if it's open on top. So a normal cube, you would calculate the area of each of the 6 squares that comprise the cube. But now I've told you that it's open on top. So you can even imagine that maybe your gran has a box of biscuits or a cube of biscuits, but the lid is off. So what that means is actually I'm going to be calculating the surface area of the cube, but this time it's made up of 5 faces, because I'm not going to be including the calculation of the area of the top square. The top square is going to be removed because I know the cube is open on top. Let's go to the board. So as I mentioned, everybody, we know that each of the dimensions will be 3 centimeters. As it is a cube, that means that each side is 3 centimeters. So I know that my length, my breadth, and my height are 3, but also we can just say that it is L is equal to 3. Sorry, I don't know why I put that 2 there. It's supposed to be L is equal to 3 centimeters. We know in general that the surface area of a cube is 6L squared. Why is it 6L squared? I know that the area of a square is length times length, which is length squared. And because a cube is made up of 6 squares, it means that the surface area of the cube is 6L squared. But I am going to have to say 6L squared minus L squared. Now, why have I subtracted an L squared? We have to remember that this top square is open. So we are going to be removing, and we're not going to be including this top square in our actual calculation because it's not going to have an impact on my actual calculation. So if I have 6l squared and I subtract l squared, that's going to leave me with 5l squared. And at this point, I'm actually allowed to substitute my length into the formula. So it's going to be 5 times 3 squared, which is going to be 5 times 9. And 5 times 9 is going to give me an answer of 45 centimeters squared. So we can know that the area, or the surface area rather, of this cube is 45 centimeters squared. Great, guys. Thank you so much for sticking with me this far. We're going to look at one more example for now, and this example is going to be a rectangular prism that's open on top. Let's go to the board. So the question says, calculate the surface area of the following rectangular prism if it is open on top. It is given that the length is 13 centimeters, the height is 8 centimeters, and the breadth is 2,5 centimeters. Okay guys, so this one is presenting slightly different to the two examples that came before, because I'm now going to have to go and actually fill in the values on my diagram so I can visualize which rectangle will actually be the one that's open on top. Let's go back to the board. So we have got our length, which is 13 centimeters. We have our height, which is 8 centimeters. And we have our breadth, which is 2,5 centimeters. Ordinarily, the surface area of a rectangular prism is 2 times length times breadth plus 2 times length times height plus 2 times breadth times height. But I've been told that this rectangular prism is open on top. So this particular rectangle on top is not present in the surface area of the prism. Now what I do want to ask you is, which dimensions does that involve? It involves the breadth and the length. So that means I'm going to have one less breadth times length calculation involved. So the surface area of this particular rectangular prism will be, the surface area is equal to 1 times length times breadth. The reason is the top rectangle is not included, plus 2 times length times height plus 2 times breadth times height. Cool. Now at this point I can substitute my values in. Length times breadth is going to be 13 times 2.5. This is going to be added to 2 times length, which is 13, times height, which is 8, plus 2 times breadth, which is 2,5, times height, which is 13. I'm going to plug this all into my trusty friend, the calculator. So we've got 13 times 2.5 plus 2 times 13 times 8 plus 2 times 2.5 times 13. And I get an answer of 305,5. So this is 305,5, you can say 50 if you want to, centimeters squared. So this accounts for the whole surface area of this particular rectangular prism, where I have excluded the area of the top rectangle, and that gives me a total of 305,50 centimeters squared.